Hi 8th grade, this is Miss B here with lesson 6.7, and today we're going to be learning how to simplify radical numbers instead of estimating them to the nearest 10th or 100th or thousandths place. In order to be able to simplify a radical number, first let's review by listing out the perfect square numbers, which is what we're going to be using when we're simplifying radicals. So the first perfect square number, which is 1 times 1, is 1. So I'm going to start listing this off, and I want you to fill in the rest on your own, and you can unpause this video. So 1 times 1 gives us our first perfect square number. The second perfect square number is 2 times 2, which is 4, and so on. So 3 squared is 9, 4 squared is 16, 5 squared is 25. So take 2 minutes to fill in the rest of them up until the 15th perfect square. In guided practice number 1, part A, we're asked, what does the square root of 16 equal? Well, 16 is a perfect square number. We have it on our list, and the square root of 16 is equal to 4. So in part B, we're kind of working backwards. What does 4 times 4 equal, or 4 squared? It gives us 16, which is a perfect square numbers. Does the square root of 16 equal to 4 times 4? And of course it does, since the square root of 16 is in fact 4. So the square root of 16 is equal to the square root of 4 times 4, because 4 times 4 is 16. So if we were to simplify this one step further, we would say that 4 is equal to 4, which is a true mathematical statement. Similarly, in part 2, what does the square root of 36 equal? The square root of 36 is 6, because 6 times 6, working backwards again, gives us 36. So again, the square root of 36 is equal to 6 times 6, since 6 times 6 is, in fact, 36. And then again, if we take the square root of 36, we get that 6 is equal to the square root of 36 again, which is 6, giving us a true math statement. So we have yes for both part C's in 1 and 2. So now let's take a look at how we would simplify an example that's not in our perfect square number list. That's not a perfect square. Throughout today's lesson, you're going to be referencing your perfect square numbers in order to help you simplify radical numbers. So another way to write the square root of 20 would be to find factors of 20 in which one of the numbers is a perfect square number. So if we consider the factors of 20, we have 1 times 20, 2 times 10, and 4 times 5. So it might help you to actually list out the factors in today's lesson. So the largest perfect square number that we have on our list is 4. And being that 4 is a perfect square number, we can rewrite the square root of 20 to be equivalent to 4 times 5. So now what we're going to do is treat each of these factors as a square root number. So now we can take the square root of 4, we can't take the square root of 5. So we're simply going to write this as 2 times the square root of 5. Let's take a look at how we would simplify 28. So 28, again, we can list our factors to help us. Factors of 28 would be 1 and 28, 2 and 14, 4 and 7. So again, in this list, the perfect square number that we have is 4. So we can rewrite the square root of 28 as the product of the square root, or you can say radical 4 times 7, which is the same as radical 4 times radical 7. And we can simplify square root of 4, or radical 4, to be 2 times the square root of 7. So it's in its simplest form when you can't break the number under the radical sign any further. So 7 is a prime number, 5 is a prime number. So these two values are in simplest form. And what's interesting, if you take your calculator right now and you put the square root of 28 into your calculator and round its decimal value, let's say to the nearest hundredth, you would get approximately 5.29. So similarly, if you put 2 times the square root of 7 into your calculator, you'll get the same exact answer. It's approximately 5.29. It's not that 28 and 2 times the square root of 7 are two different numbers. We're just writing it in a different form. It's like simplifying a fraction, right? We can reduce 2/4 to 1/2, but they're still the same value. It's just written in a different form. So do the you try it in number 5 and 28. I'm sorry, in number 5 and 6, we have the square root of 50 and the square root of 28. You know what? We're going to change that on our handout. Let's change that to the square root of 300. I'll be sure to have it printed as the square root of 300 on your class handout. So unpause this video for the solution. It should take you about 2 minutes to get through. Unpause the video for the answer. Okay, so in simplest form, the square root of 50, or radical 50, is equivalent to 5 square root 2, and the square root of 300 is equivalent to 10 times the square root of 3, or 10 radical 3. Now, I wonder how many of you, let's say with this first example here, did the square root of 5 times 10. Was this able to get you anywhere? No, because 5 nor 10, neither 5 nor 10 are perfect square numbers, so we're not able to break them down. So again, you're going to reference your list of perfect square numbers written at the top of your handout to find factors of the given number that are a perfect square. So just one more thing. Similarly, in example number 6, some of you may have taken 25 to be one of the factors of 300. So 300 we can simplify to 12 times 25. So if you if you take the square root of 25, we'll get 5 radical 12. But this answer is not in simplest form because 12 has another factor that is a perfect square, and that's 4. So we're not done simplifying this. You can break down the bigger numbers in smaller steps. Let's go back to the purple. Purple's nice. So we can rewrite the square root of 12. So we still have, whoa, what's going on? We still have 5 on the outside, and we can rewrite 12 as 4 times 3, or 3 times 4. And again, we can take the square root of 4. So what you're going to do when you factor it out is multiply it by the number that's in front of your radical. So we would have 5 times whatever the square root of 4 is, which is 2. 5 times 2 times the square root of 3, which will give us a final answer of 10 radical 3, which is exactly what we had when we took, when we rewrote 300 as the product of 103, right? It was one step less, but again, it's not incorrect to take this longer route. So with the bigger numbers that you have in your classwork today, just make sure that it is in simplest form, that you can't break down the number that's under the square root symbol, that's under the radical sign anymore. So you guys have approximately 30 minutes until your next period for our morning session. You're going to work through the next 2 pages. So be sure to stop on at least number 23. Have a great day.